video, I will be solving some problems of application of the integral. We are going to be speaking about the total change of a function when the function is taking values from a to b. So in this type of problem, we know the rate of change of the functions and we want to know the total change. So we know the rate of change, that is the derivative. The total change of the function when x takes value from a to b will be given by the integral from a to b of the rate of change of x by dx, by the differential of x. For example, if we have, suppose the rate of change of the number of hours it takes a worker in a certain factory to produce the x item is given by this formula. So we know the formula of the rate of change. And the question is, what is the total number of hours required to produce the 8 first items when this x changing from 0 to 8? So to compute the total number of hours required to produce the 8 first items, what we are going to do is getting the integral from a to b of the rate of change dx. We know that this is the formula for the total change, and in this case we are producing the first 8 items, so it means that from the item 0 to the item number 8, the total change in hours, so actually the number of hours, because at the beginning was 0 hours, will be the integral from 0 to a of 24 minus 1.5x dx. So getting this integral, so remember this is the definite integral. You can use the fundamental theorem of calculus. The integral of 24 is 24x minus the integral of 1.5x equal 1.5 over 2x squared. So I'm going to type here 1.5 over 2x squared. We don't need to use a constant of integration here because this is a definite integral. This evaluated in 0 and 8, so I'm going to evaluate this in 8 and then minus the same function evaluated in 0. So it will be 24 multiplied by a minus 1.5 over 2 multiplied by 64, that is a squared, minus the same function but now evaluated in 0. So minus, so all the function evaluated in 0. By the way, this is 0, this is 0, so this is 1.5 times 64 over 2, this is 32 multiplied by 145, that is 48, will be 24 times a minus 48, and this will be 144. So we'll have 144 minus 0, and this is 144. So it means the total number of hours required to produce the 8 first items is 144. So this is an example of how to use the total change formula. Let's make another example. The rate of depreciation in dollars per year for a certain truck is given by this formula, where t is the time in years and t equals 0 is the years of purchase. If we know how long from the company purchased the truck, so you can put here the time and you're going to get the rate of depreciation. And the question is, what is the total depreciation at the end of 4 years? So I'm going to find, this is the rate of depreciation and we want to know the total depreciation at the end of 4 years. At the end of the 4 years, so it means from year 0 to years 4. So if I want to solve these problems, and this is the total depreciation, and I know the rate of depreciation, so the total depreciation will be the integral, this is the formula, from a to b of the derivative dt. And in this case, will be the total change will be the integral from 0 to 4. So it will be the 0 of the function dt. And now, just solve this integral. For solving this integral, I know it will be an easy problem if you use substitution. So you make u equal 1 plus 0.4t plus 0.15t squared. This is u, so you have here at the bottom u squared. Get the u, and you're going to know that the u will have these factors. But anyway, you can use a software. I used GeoGebra to compute this integral. That is not difficult using substitution. Okay, I use GeoGebra, and in GeoGebra I just type the function and then get the integral of this function from 0 to 4. And GeoGebra give me, remember, if you put integral and you put the function and two values, GeoGebra is gonna compute the definite integral, and in this case will be between 0 and 4, and I get 4640. The total depreciation will be $4,640. So the total depreciation at the end of the 4 years will be $4,640, and that's it. So you have two options. You can use this. You can get the integral using integration for substitution, and then use the fundamental theorem of calculus. If you use GeoGebra, GeoGebra is gonna give you not only the solution, but it's gonna make a graph of the function, and this is the graph of the rate of depreciation, this green one here, and the area under the curve, that is the definite integral, is also symbolized here. So it would be 4,640. Okay, with this I finish explaining this problem. I hope you have found it useful. Thank you.